Well, hello everyone. So here's a demo of using our scheduling Solr apps. And the first step is going to the website, the GitHub website, and go to the first release. Or I will also share the link of the Google Drive in the chat. And therefore you can go straight to the Google's Drive uh, and download the zip file. So since the zip file is 2.5 gigabits, which is too large to upload to GitHub. Therefore, I use Google Drive. And if you follow the link, here's a zip file. After you download the zip file, uh, so for example, if I download the file and I unzip it, and you will see the dist file, and double click, you will see the app entry, and just going through that, and you just need to double click the exe file, the app entry, and you will just turn on the terminal and also go straight to our website. And the first step is click the trim models. If you haven't trimmed any models, for example, here I trim part of it. I trim the regression model, I trim the tree model, I trained the tiny MLP, but I didn't train the genetic algorithm, so there's no results here. So the first step for every first time users is to choose file, upload, and also train. So here's how it works. You click choose file, find the Excel file you want to upload, and click the upload, and you will just tell your file upload. If you upload like the CSV file or other type, it may tell you like the file is not upload success and you need to upload only the Excel file. And after you upload the file and successful, you will have the button start training and you will say the training progress. This progress will take a long time, and one way to check is it working is to check on the terminal. So first, it will just pop out the post upload 200, which means it uploads successful. And after that, it will tell you debug train is running, which means the train is starting. And the first training of the model is, I think it's the MLP model, and it will have the early stop. And after the MLP, it will just tell you like the RMC, the MAE, the R square. And second one is tree. Third one is linear regression. And the last one is genetics. However, the genetics will take like 100,000 loops. So therefore, it will take a long time. If I remember correctly, for the first time training, it will take at least like 45 minutes to finish for the genetic algorithm. And since it is too long, I will just like stop recording and give it time to train. And we may see you later after you finish. Hey guys, so here's our models finished training, and since it's already finished training, there will be no outputs right now. You don't need to care about the terminals. And after, if you finish the training, you will see all the results here. For example, the different models graph, the prediction vs actual, and the RMC, the MAE, and R square. So we use R square to evaluate how well the model is. For example, if the R square is so it is ranging from negative infinity to 1. So if it's very close to 1, it means the model is best, and the R square will not be over 1. and it will just be like smaller or equal to 1. And the more closer it gets to 1, the better it is. And you can check the results for the like genetic regression tree and MLP. And one way to double check, have you trained the model is when you click the train models, if it show up the graph and also the data, it means yeah, it finished training. So all of these data are saving in your users, your name, and here my software checkpoints. And I will explain this later in the program explanation, but right now all the data, all the graphs, all the MSE, MAE, R-square you using on the website are saved here, and do not delete it or you need to train the model again. And after you doing the train models, you can do the predictions. If you don't train the models, if you don't see any graphs or data here, you cannot predict, or you will just tell you the wrong outputs, and you want not to have a good prediction if you don't train the model. So for example, you are just entering the numbers, like for the tilt, panel quantity, system rating, and for the entering text, right now we are only provide the options provide in the Excels. If you want to have like a new kind of like the inventor manufacturer or new kind of array type, you may not be able to use this program to help you predict because we haven't trained the model of the unknown type of input. And you can also like choosing something here, maybe this, yes, arrays, circuits, reinforcements, yeah, and maybe unknown or flash fit to stories, maybe 5 workers. After you finish all the information entering, if you want to change something, just hit previous and you can change it. And after you finish, just click submit. And you will have the calculations from here. And then just tell you the time, which is 2000 minutes. You can also change models. And if you click to the train models, this form, I don't think you will save your results, so you have to re-enter everything again. And here's how we use training and prediction. And for the instruction explanation videos, here you may pause and maybe leave the video and try yourself. And I would like to explain how this works, or like what makes this works, which means I would like to explain the code, the idea behind the website. And this part is more specifically like for those who want to download the code and try to do some tiny changes, and I would like to explain how each program works. And let's start with our backend and front end. So as you can see, we are using a website. So this website is kind of like the front end, and it will not do any calculations. Like if you go to the console or the terminal, you will not see any calculations doing like on this page. But you will get the results or like doing the calculation like oh yeah, you finished calculation. Oh yeah, you got this, and the prediction time is what, blah blah blah, from the backend, from like here the information like debug or other part. And our program can split into like two parts. One is front end, the website, and one is the back end. And I would like to start with the front end first. So to think about how the front end and back end works, just imagine you are walking on the street and saw a car. And the car, you can see the color of the car, the window of the car, the wheel of the car, the door, everything. And those are the front end. It is something you are seeable. You can do the changes. You can do the reactions. You can enter in something. That's the front end. However, for the back end, it's more like a calculation or like the engine in the car. It makes a car moving. It makes a car can turn the lights, turn off the lights, up the window or down the window. And that's our back end works. So start with the front end. So front end, we have like this 4 HTML file and a static. And thanks to our teammates who do a very, very good job on our front end building, especially the pictures, the styles, the pictures here, the logos here, and this 4 HTML building. They did a very good job on this to build our website. And for the form, it's just like the predict installation durations. And for the index, it refers to the home page. For the instructions, it refers to the instruction page. For the train, it refers to the train page, which has like the train upload button and training button. So if you want to do something change to the website, remember, not to the calculations or predictions, but only to the website, please go to the web file and change the code there. After talking about the web one, we are going to talk about the backend. But before that, let's talk about the connection between the front end and the backend, which is our main program. So we are using Flask here. Flask is a structure that for Python to running the website. So in the future, if you want to have a fancier or safer website structure, please use Django or others. And Flask for right now is like easy to build with, but maybe not good to use with for a long time. And something you can change here is the path for different things, like the basic direction, user direction, or checkpoint direction. So I put this 4 lines in every single code which need to save files or read files. And if you want to change a path, like if your disk C disk is very full and going to explode, you may change your user direction to another, maybe change to disk D and change the path to another things. But for right now, I'm saving all the data. Where you can see right now is in the C disk under users. So like here user path reference to here. And here's how main works. It's just like connection between front end and back end. And every single time you just call the main and it will start the program. And after that, we are doing the data loading, which is very important. So based on our client, they provide 23 variables data and like 378 lines of data, and each line of data has 23 variables, and each variable can have like the name of the roof or the something else, and also we need to change those into the integer or the values we can calculate with. And also for the like seasons, we are mapping them around so that we can give them like 1, 2, 3, 4 numbers, and later to easy calculate with. And the reason we have two different data loader because we are using old one for genetic algorithm and new one for the other three methods. And the difference between the new one and old one is the new one will return 6 values, including the x, y, and also the scalar of them. So since for decision tree, MLP, and also the linear regression, the larger values will have larger effect on them. So we have to scale them, make them smaller and easy to calculate with. So we are doing scaling here. And the old one doesn't have the scaling, it just returns the values of the original value. And something you may need to change in the future if you like, or if you want to explore more, is here exclude columns. So right now we are putting nodes in the exclude columns, but actually this is not allowed, or we are not going to exclude nodes because nodes are sometimes very important and very impactful for our prediction, so we have to change it. But for right now, since we have like different kinds of nodes, we cannot just label them like this node is label 1, this node is label 2, so I will just exclude the nodes. After talking about the data, here's our EXP and models. So I would like to explain the models first, and also then the train, then the predict engine. So for models, we have our tree model first. So tree, which stands for decision tree. So for those people who don't know the decision tree, here's a very, very good graph I can find. For example, you are purchasing a car. You are doing the decisions, and you may consider something. For example, like, is it a color I like? What year it makes, and what brand it makes. And the result would just be like buy or not buy. And for our models, it will be like, we have the installation season in winter or not, the tilted angle bigger than some number, or we have more workers or only 2 workers or only 1 worker. So it's kind of like a tree, and you are making decisions around them. And the progress of the models is kind of like it's building different nodes. For example, like you may arrange tilted angle first, then the season, then something, then something, then build something here, then build something here. So while you are training, you just put different nodes on different place and connect them with like yes, no relationship. And here's our tree model works. After that is our MLP model. MLP, which is one type of the deep learning. Deep learning uses the idea of neural networks. Neural networks just kind of like our human brains. And here's how it works. It's kind of like the tree model or the decision tree model, but just imagine like there are a lot of decision trees and they are connected to each other, and each node will have different point out you will have different lines to connect, not only one. So like decision tree has only like one out, one, two out, two out. It's like a binary tree. But deep learning is not. You will have a lot of out and a lot of in. So here's how it works. You have an image, for example, and you are going to like, is this a circle, a triangle? Does it have ears? Is this nose? Is this fur or not? And then after that you have, is this a cat? And come back to our code, it will be like this. Lot of trees combining, lot of like decision trees combining, and come up with the neural networks or the net of the deep learnings. And in the future, if we have more variables, you may change the 32 to like 64 to make it larger to train, and you will have better outputs in the future if you have more like datas. And after that, it's a linear regression. So linear regression is very basic model. It's kind of like you have a group of dots and you try to find the best fit line of those dots. And the last one is our Solr genetic algorithm model. So to explain the genetic algorithm, we are also using graphs. So for example, we have like 300 lines of data. It's like here. We are doing selection. And after that, we are using the fitness function to evaluate each line to find the best fit, which means if the data is very useful or has very good impact on learning, we are using it in the next generation. You can understand the generation as rounds. We are using that line of data for the next round's learning. If this is not that useful, like it is an outlier, we are not using it. So the step 2 is a crossover. For example, we're just changing some parts around of the useful lines of data and crossover, making them like different from before, and try to see like, is this crossover working? For example, like the green one is stolen in winter, like the first box in winter, second box 5 workers, third part tilt angle bigger than 30s. After that, we're just like doing switching things, like maybe here winter in another combinations, and the blue one is in summer, so summer goes here, winter goes here, worker like 3 worker goes here, 5 worker goes here. Like we are mixing them around, and we are using fitness function to evaluate this combination working. If it has a higher fitness function, means like, oh yeah, this crossover working, or this order is working. If it has low fitness function score, then it means like we may not cross over this two. It means not a good combo, so we are not using it. And after that, we are doing mutations, kind of like grouping around and just inserting different nodes, inserting different parts of information to another combinations, and just like mapping around and doing the crossover again, doing fitness calculating again, and after that, after rounds and rounds of generations, we may get the highest best fit, and that used to predict our time for installing solar panel. And after that, we are going to talk about the train_new.py, which is our train function to train all the models. So in here, we are training all the models, and we train the tree and linear regression here, and train the MLP here in the under the train static model, and train the genetic under the all models. And after all the training, it's going to save all the data and outputs the image you guys see on the train website. So when you go back to here, these pictures, these data are coming from train new program. And the last part is our genetic, it's our predict engine. So the predict engine is kind of like going backward from learning. So learning is kind of like we are learning a pattern. The machine, no, not we. The machine is going to learn a pattern between different inputs and how well make the outputs out. And for example, my personal guess, like if it's in winter, you would take a longer time. If it's in fall, you may take like shorter time. And the machine is going to learn this pattern and doing adjustment. Like I'm saying longer and shorter, but actually 10 minutes longer or 100 minutes longer, I don't know. I just doing like I guess. But the machine is going to do the actually calculations and predictions. And to predict which model, you have to first, the way it's doing like, after you input a form, then you will send the form, like here, you will receive the features like 20, 12, 3, 7.7, solar edge, roof mount, blah 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 blah. And going send this informations to the backend. And then you will start doing the mapping things, which we talk about in the data loaders. So things like for the solar edge, for the roof mount, for the yes or no, we don't know the integer value. The machine cannot learn just basically from the text value. They only accept like numbers. So we are just doing numbers. So we are mapping and changing them into numbers. And after that, you just like provide 23 features or 23 variables, and you are just doing the calculations, matching like 20 is the tilt, 3 is panel quantity, like number of stories 1, kind of like matching around, and after that doing the calculations. And after doing the calculations, it will give you the predict value, and you will just have like because we are doing scaling, so you will be a very tiny number, and after we have the initial values, we are adding or multiplying the bias and make it as our actual time. So for example, like it may predict like 7, but after the biased calculations, it will become like 2200 we see. And here's how all the programs works and the basic ideas behind the program. Thanks again for watching this video.